Another thing about batteries, so because these are lead acid, as you charge them, when you do the last little bit of charge, they boil off water. Actually, boil isn't the right expression. It's not boiling. It's electrolyzing or whatever, and hydrogen and oxygen will bubble out of the water. But that actually consumes some water. So once a month, I have to fill them up with water. It costs me about $3. What I do is I just put a gallon of distilled water on the roof of my truck, and I have a long piece of surgical tubing, and I just siphon a little bit and then just fill up the batteries. And you can see down in the top, and you just top them up about once a month. Again, that's the regular maintenance for a car like this. Pretty cheap to run. In regards to how much it costs to run, more about that, as far as I can tell on my electricity bill, I can't detect it. So I figure it's costing me $20 a month or less to operate this vehicle. Other people I suspect would drive more than I do, but I'm not limited. I don't sit at home. When I need to drive somewhere, I drive it, and I'm using so little electricity I can't detect it on my bill. One other thing, just to come back to the lithium ions, so they cost about 5 times as much as lead acid batteries, but as I explained, they last so many more years and you get so much more range that it makes the vehicles viable even today. In fact, back to the EV1. So, they started out with lead acid, then they went to nickel metal hydride. If General Motors were to turn on their factory today, because the car companies talk about how electric vehicles aren't viable or they're going to take too long to spin up the production line or whatever. Well, General Motors has a production line. It's called the EV1. They, I'm sure, still have all the tooling and the designs and the schematics and all that stuff, and if they wanted to make more EV1s today, they could. But if they were to make them today, they could make them with lithium-ion batteries. And admittedly, I'm guessing here, but the second generation EV1s had a range of about 120 miles. At least that's what they documented. With the lithium-ion batteries, now you're talking 250 miles on with that vehicle. That makes it an extremely viable, saleable, workable car for a vast majority of the population. So I think General Motors should turn that factory back on immediately. That's my opinion. This switch is to control my heater, my cabin heater. Now, of course, I don't have a gasoline engine anymore that makes heat. So my heat has to come from electricity. These two indicator lights here, they might be a little bit hard to see, but those tell me the condition of my motor controller, which I will cover. But when I start the vehicle, or when I turn on the vehicle, these two lights come on, and then when I hit the starter, these two lights will turn off, telling me that we're ready to go. This thing here is an emergency shutoff knob. I never use it, but it runs up front into my engine compartment, and it switches off a breaker. So if something happens and I'm worried, then I can pull that. And it's just a pull knob. In fact, there, that's how you turn off the vehicle. So there's a heater that came with the kit. The heater core it's about that big or so, and it goes into, or it's now installed into my ventilation system. So when I turn on the heater, it gets warm. One difference with a vehicle like this is the heater switch doesn't connect to the old vehicle really in any way to tell it what's going on. So like my dial here that used to adjust the temperature of the cabin doesn't do anything anymore. But this still turns on my fan. So I have to remember that if I want heat, I have to turn on the heater and turn on the fan. It's a minor thing. That's really about the only thing that makes this vehicle different in how you operate the vehicle. So this is a Xantrex battery meter. It tells me how much power is in my batteries at any given time. It actually tells me a few different things. So right now it's telling me that my battery voltage is 165. Well, the actual rated voltage of my battery pack is 156. That's above that voltage, obviously. Essentially, that's telling me that my battery's all charged up. The next selection is telling me how much current I'm using right now. So current, a good analogy to think about it is think of electricity in comparison to water, or water in a pipe. Voltage is how much pressure it's under, and current, or amperage, is how much water there actually is. Well, right now I'm consuming 0.4 amps. That's very little, less than a household light bulb. But the car is off, of course. When I accelerate, that can hop up to 300 amps or 500 amps, depends on how hard I push on the gas pedal or the accelerator pedal. The next selection is how much electricity have I used? Not how much am I using, but how much have I used? So far, because I just charged up the battery pack, I've used 0.3 amp hours, which is very little. That's 0.3 of an amp for 1 hour. Not much power. The next selection tells me how long I could continue to do what I'm doing. So right now I'm using very little power, and so I could carry on doing that for 255 more hours. 255 is actually the calculated maximum. It won't go to a number bigger than that. In other words, I could carry on like this for a very long time. Now that number's obviously going to go down a lot if I start driving. So on the dashboard, most of the dashboard does nothing now. Like obviously my gas gauge doesn't work, my 12 volt battery gauge does work, my engine temperature doesn't work, my oil pressure doesn't work because I don't have oil pressure and I don't have an engine temperature. The tachometer is driven by my Zilla controller. The tachometer does tell me how fast my electric motor is spinning, and it's accurate. In fact, it's very accurate, so you can see that the motor is spinning. The Zilla can also be configured so that this will show me my current, so I can see on a dial gauge exactly how much battery power I'm pulling. Kind of a nice thing, because the less you pull, the more you get out of your batteries. My speedometer does not work right now. It will. I have a little device called a Dakota Digital SGI-5. It's just a little computer that listens to the ticks coming off of the transmission and converts it into a signal to run my speedometer. The original came from the engine computer, and of course the engine computer is gone now, so I don't have a speedometer at the moment. So this is the front end of the car, obviously. The gasoline engine is gone, obviously. So let's cover a few things under here, starting with this, which is the main control box. My wiring is a mess, and one thing I can guarantee you is if you have an electrician do the job, he'll do a much better job than I did. But although it looks like a lot of wiring, believe it or not, it's really quite simple. It's kind of 2 wires in, 2 wires out, but just a bunch of different times, and let's cover some of that. So in here, well, first of all, this is live. I haven't turned the power off, so I'm not going to stick my fingers in there too much, but a couple of things. These 2 relays, one of them is for the logic, so when I turn on the key, this relay ticks over and it tells the hairball that we're ready to go. Forgotten what the other one's for. I can figure it out though. Anyway, so the main thing in here is the hairball. Now the hairball is half of a 2-part system. The hairball tells the motor controller, the Zilla motor controller, what to do. The hairball has a couple of different signals. So for example, it's got a signal coming from my reverse. So when I put the transmission into reverse gear, it sends a 12 volt signal to one of the wires in there saying, I'm in reverse. That tells the hairball not to deliver so much power because you don't want to burn out in reverse. Another signal into this is that I've hit the key switch and I've hit the starter. So when I go to start, the hairball does a couple of checks to make sure that everything is okay. The lights inside my cabin that you saw are driven by this hairball interface. So it'll turn those lights on and off depending on if there's an error or what have you, or over temperature or whatnot. Another signal feeding into this is a tachometer pickup. So at the end of my electric motor is a little magnet spinning around. There's a cap over the end of that magnet, and there's 3 wires coming off of that cap. The 3 wires, there's no real voltage on there. It's a signal so weak you wouldn't get electrocuted by it. But there's 3 wires coming off of there, and they feed into the hairball. They tell the hairball how fast the electric motor is spinning.